function y equals sine 3t and cosine 4t. It's not hard to show this is a periodic function. What is the period of this one? 2 pi over 3, and period of that one 2 pi over 4. It definitely repeats this pattern over 2 pi if you look at the graph, and it's not hard to show by plugging in 2 pi in here, 2 pi it repeats because it's integer coefficients. But definitely this is not simple harmonic motion, right? Simple harmonic motion have this one simple amplitude, right? But this just keeps changing. Overall, it has this all wavy motion, and on top of it, it has its own wave built on top of it, right? It's interesting wave. So, is it possible to write this one as simple harmonic motion? Sum of amplitude times cosine of omega t plus different amplitude of something like that. Alright? And it's possible, and that's what we're about to do. It's a little technique. We're using addition and subtraction formula. So I'm going to write that down for you here and introduce the technique. And this is going to be part of quiz 4.1 that's going to be given tomorrow morning. Not morning, at the beginning of the class. So learn that technique and you'll be able to understand the formula easily. So think about this one, Fourier analysis. This looks like a part of addition and subtraction formula. Would you agree? Right? Right enough? So what comes to your mind? Sine of what? Do I have to look at it here? Such that this one shows up inside. Not just this one. This is a part of that formula. So what should I add this two things so that I see sine of 3t and cosine of 4t? Anyone like to try? Is s plus 2, let me say x and y, right? X and y. What should be this slot and that slot? You apply addition formula, so it looks like we have sine 3t times the cosine 4t shows up. Right. How about sine times cosine? Does it? That's related to addition formula of sine, right? Addition formula of sine has sine times cosine, right? So it looks like a sine of this thing times the cosine of that thing, right? Plus cosine of the first term and sine of second term, right? What do we want to put here and there? If you want this one to show up, what should we want to put it here? How about that one being exactly that? Would that be alright? So can I put 3t and 14 there? Then I have that one exactly matched there, right? Then I don't have any choice. I have to fill in 3t, 4t here, right? That's the formula. So how about here? 3t and 4t. Is that correct? So once I write this one down, it's very easy to see this is correct. Because here is my x and y, sine x and cosine y, and cosine x and sine y. That's addition formula. Does that make sense? Yeah. But left-hand side has actually simpler expression. What is it? Sine of 3t plus 4t is equal to... This does not require addition formula. It just requires simple addition. 7t, right? Sine of 7t, that's a simple harmonic motion, right? Sine of 7t with amplitude 1, with omega 7. But this can be complicated like this. Alright? Does that make sense? Alright. So I have this thing, and only thing we want is this one. We don't want the other one, right? So we're going to consider the same thing. There's another formula that has a sine 3t and cosine 4t. Do you know what that is? It's not cosine addition formula or subtraction formula, right? Cosine is cosine times cosine, sine times sine. what would be the sine of something that such that we have this one again? Tangent doesn't have sine and cosine in it. It's not like this, right? Sine of addition and subtraction formula looks always like this, right? And I want to have this 3t, 4t again, right? But what should be here then? The 3t minus 4t, then we have this once again. Then here's 3t and 4t there, and difference is minus there. And this one looks like what? Negative sine of negative t, correct? But do you remember something called even and odd property of sine? So that you can do something about the negative? Is this negative disappears or being pulled out for a sine case? It's about first quadrant and fourth quadrant. Sine is a y-coordinate. Is it t versus negative t to you? T versus negative t. The y-coordinate changes? T radian versus negative t radian. Here is quadrant. T radian here, negative t radian here, right? Does y-coordinate change? Yes, change the sign, right? And that's this value. So this one, y-coordinate, is y-coordinate in the first quadrant negated. But cosine doesn't change, right? Cosine is x-coordinate. So cosine of negative t is positive cosine of t. They're equal, not opposite sign. So this thing had simply simplified to sine of 7t, negative sine t, but it has complicated expression like that. And all we want is just this guy here, related to simple harmonic motion. And we want to get rid of this guy. What operation should we do to this two equation to get rid of this and keep this guy? I have two equations. I want to manipulate this equation. We get rid of this one and keep this one. Add them together. If you add these two equations together, this guy cancels, right? And this guy is just twice. Not bad. And this one is a simple harmonic motion. So I have sine of 7t minus sine of t is equal to 2 times the sine of 3t times the cosine of 4t, right? And the other two terms cancel each other, plus minus. So what is the last bit we have to do? Our goal is this sine 3t times the cosine 4t. That looks like really neat, nice motion, but it's not simple harmonic motion. But look at left-hand side here, right? That's the sum of simple harmonic motion. So if you divide that, 1/2 amplitude goes in there, and negative 1/2 goes to that. And now you see these two, simple harmonic motion with half of the amplitude and simple harmonic motion with half of the amplitude, negative, different frequency, right? So what have you accomplished? We identically wrote this one as a sum of simple harmonic motion, which is called Fourier analysis. All right? So what was the key? You look at 3t and 4t, right? Look at how it's combined. Sine and cosine must be sine formula. Write down addition formula and subtraction formula. By adding and subtracting, you will get to this guy. That was the idea. So we'll practice with one more with this type, but let me show you the picture. This was the original wave, right? And I'm comparing that. I don't have it here, but I thought I had it. You can sketch these two motions separately and combine them and sketch it, and you actually get this exactly the same thing. All right? So this is doing calculus with this one, very tricky. Here it's very simple. That's a second application in mathematics of this thing. All right, let's practice one more problem like this one, cosine 3t and cosine 2t. And we're going to write down overall a formula. So this is exercise number 1. Let's just end the first hour there and enter new one here. All right. So let's think about it. What formula are we going to consider? Sine formula, cosine formula? Cosine formula, because cosine times cosine, right? What if this were sine times sine? If this were sine times sine, are we going to consider sine formula or cosine formula? Cosine again, because sine times sine appears in the cosine formula, right? All right. So I want you to write down addition formula and subtraction formula, you know, on top of each other. I mean, in the two rows. And consider adding and subtracting and things like that. Okay, how was it? All good? So we have sine times cosine and did cosine times cosine, and there's a sine times a sine, and this also comes from cosine formula, right? How about cosine times sine? Like that? Well, that's the same as sine times cosine, right? So those are the examples they have. Fair enough? So see if I don't think I have addition and subtraction formula written down. But here I'm showing the problem there. For example, here, cosine times sine, right? Which formula are we using? Sine formula, right? If it mixes sine, the same cosine, it's that simple. So write down those two formulas and that'll do it. Any question about these problems? Is that right? So tomorrow, I thought I updated this one, but it's supposed to be quiz 4.1, and tomorrow is July 26th, and that's the quiz that we're going to have. About stating the product to some formula, that's Fourier analysis, and proving the formula, which is, if you do all the cases, this kind of takes a long time, so I'm just going to choose one. All right, so let's write that down. This is called product to some formula. But if you look at what we just did, I hope that makes sense. Here's a product of two trigonometric functions, right? And it turned it into a sum of trigonometric functions, right? It's just a product to some formula. So if you have sine A times a cosine B, right? You just went through the examples. So can you just have that addition and subtraction formula over your head, right there, of sine, and to get this one, right? We looked at sine of A plus B, right? Then if you expand it using addition formula, you have this thing come out, right? And we consider sine of A minus B, correct? We have that up there. And then, did we add or subtract? We added these two things, right? And then there's 2 copies. And we divided both sides by 2. So we end up at this thing there. Right? So that's the summary. So if you have this one, you don't have to write this one all the down all the time and add them together and do that. Just simply use this one, right? So tomorrow is about you memorize this one and write it down and choose only one just to prove it and explain it. And in the test, and you don't have to prove anything, just use a formula. But I want you to understand the principle behind this formula and meaning of this formula. Does not look like a simple harmonic motion. Can be written as the sum of simple harmonic motion. Alright? Here's the second formula. Second meaningful formula we're going to do is a cosine of A times a cosine of B. We just did this one, right? It came from which formula? Cosine formula, right? So either we're going to both add and subtract. I want you to think about addition and subtraction formula of this cosine over your head, and or think about what we just did. Did we add or subtract to get cosine times cosine? Think about this formula. Have that in your mind. Cosine A minus B. Also picture that in your mind. Did we add or subtract to isolate cosine and kill the sine times sine? Cosine times cosine, sine times sine, right? Think about the sign, S-I-G-N, plus minus in front of it. What did we do to this two formula to get that one? Add or subtract? We looked at cosine times a cosine minus sine times sine, right? The other formula is a cosine times cosine plus sine times sine. To keep this one and isolate that, we added this two, right? So we can add. And there's always 1/2. And you know where the 1/2 come from, right? As you add, you have two copies. So that's the second formula. Third formula, what's left? Sine, right? Sine times sine. What about cosine times sine? That's the same as this one, right? You can rearrange it, change the role of A and B. So right, so we haven't done this one, but I'm showing you what goes with this cosine formula there. So I'm going to write down cosine A plus B, cosine A minus B. If we want to keep this guy, right? We want to keep this guy and kill this one. So we're going to do opposite. We're not going to add. We're going to subtract, right? We have two choices. Are we going to put the negative here or negative there to make things easy? Here's a negative, right? So if I put negative to the sum part, this will be negative and positive. So then add it. It'll do it. So if you put negative here, this one will change to positive, and that's going to be negative, right? Then add the negative and positive, cancel. And this one changed to positive, so two copies there. So 1/2 goes there. So pay attention to the third one. This is where the mistake again. Sine times sine is derived in that form. So anytime if you have sine times sine, cosine times cosine, or sine times cosine, you can write it as a lot better form for physics and calculus. Both of them. This is called product to sum formula. Alright? So how about this part here? Prove the formulas. How are you going to prove this formula? Write down, for example, if you want to prove this one, left hand side is simple enough. Simplify right hand side, right? So proof of formula formula star. Does this symbol make sense? Star represent this formula, right? What do you do? Right hand side? Correct? What's right hand side? 1/2 of cosine of a plus b, right? What's cosine of a plus b? Cosine a cosine b minus sine a sine b, right? And there's one more term, plus 1/2 cosine a minus b. What's cosine a minus b? Cosine a cosine b. Subtraction is a positive sine a sine b, right? Now you see there's two copies of half of cosine a cosine b. So there's one copy of cosine a cosine b. This thing as an opposite sign, sine a sine b, negative 1/2, sine a sine b, positive 1/2. Therefore, it's a 0 times the sine a sine b, right? So that's equal to right hand side. Sorry about this, left hand side. So that's a proof. How did they discover this one? That was the idea before. Why is this true? This is simply justifying why this one is true, not really explaining how they discovered it. But if you look at the proof part, you can kind of imagine, oh, this must be how they discovered it or something. So